This is another just a quick tutorial into basic digital audio principles, but also setting up for a digital recording in Logic. Okay, so basically we're in our project here, and we need to set up digital audio recording. Okay, so when recording audio, which you shouldn't need to do really on these computers in the CMS class, but you may well do over at Extreme Studios because we've got Logic on the computers there. When recording audio, Logic saves the data as a digital stream from the audio interface that you've got on your desktop, the M-Audio Fast Tracks, to an audio file on your hard disk. Assuming you've got the correct settings, Logic does not exert any influence over the quality of your recordings. By choosing the right recording environment and using high quality components in your signal chain, you can also ensure that the quality of your audio recordings will be the same as the quality produced by a professional studio. So, whether you're using the M-Audio device or we've replaced that with a new device, you are limited by the quality of the device, obviously, but these ones are perfectly feasible for what you need to do. Okay, over Extreme, you've got a better audio device for recording at high quality. So in the following exercises, we're going to set up Logic to prepare for a music recording intended for use on an audio CD. But first, just a little bit about digital recording sample rates and bit depths, so we understand a little bit about digital audio principles. When audio is recorded in Logic, sound pressure waves are turned into a digital audio file. So a sound pressure wave is your voice or any other sound travelling through air into a microphone. Okay, that's sound pressure, and that sound pressure is turned into a digital file. Basically, the microphone turns it into an electrical signal, and that electrical signal is turned into a digital data stream, which is recorded by Logic. Okay, so first of all, the microphone transforms that sound pressure wave into an analog electrical signal. Analog just means analogous. So for every time the tiniest of changes happens in that sound pressure, that sound pressure is hitting the microphone diaphragm, and those minute changes are being recorded as changes in electrical current. Okay, because as the microphone diaphragm moves in between a magnet, or as the case with condenser microphones across a capacitance difference. It changes into electrical signal, and those very, very discrete and continuous changes in electrical current are recorded as digital audio. Okay, and that's what we call analog to digital conversion. The microphone preamp inside your recording device, your audio device, your sound card, whatever you want to call it, amplifies the analog electrical signal. Okay, because microphones generally are quite they don't have a very, very high amplitude. So it amplifies it. That's what the preamp's for. So a good preamp really does make a difference. But generally the preamp is there to push it up to line level, okay, which means it's a recordable level with a good signal to noise ratio, meaning you got a good signal, a loud signal without too much noise. Okay, and the better the preamp, the better your signal to noise ratio. Okay, so the microphone preamp amplifies the analog electrical signal, and a gain knob on your device lets you set a proper recording level to avoid any distortion. Obviously, you're listening while you're doing this. You've got your headphones on, you're making sure you're not getting any distortion. The analog to digital, or what we call an AD converter, transforms the analog electrical signal into a digital data stream, as I explained. The audio interface sends that digital data stream from the converter to the computer. And then Logic Pro saves the incoming data as an audio file displayed on the screen by a waveform presenting the sound pressure waves. To transform the analog signal into a digital data stream, the converters sample the analog signal at a very fast time interval, what we call a sample rate. So as the sound is coming in, it's being sampled a certain amount of times per second, and that's the rate at which it's being sampled. That's the sample rate. So the sample rate identifies how many times per second the audio is digitally sampled. Okay, how many times per second a digital number is created to represent that waveform at that particular moment in time. The bit depth, what we call the bit depth, identifies the number of data bits, i.e. the number of noughts and ones used to encode the value of each sample. So for each one of those samples, we need a value, okay, and the bit depth will give us an amount of noughts and ones that we can use to describe that sound at that point. Okay, so we take a certain amount of samples per second, that's the sample rate, and then for every one of those samples we have an amount of bits, an amount of noughts and ones that can represent the level of that sound. Okay, so the sample rate and bit depth settings both influence the quality of a digital audio recording, obviously, because the higher the sample rate, the more samples you've got per second, the more you can describe the exact nature of the curve of that audio as it comes in, okay, as it rises in volume and then becomes more quiet. Most audio interfaces include converters, and many include also microphone preamps. Any good ones anyway. Also, the modern Mac computers ship with a built-in audio interface anyway, so you don't necessarily need that, but I wouldn't actually use that for anything other than just recording very basic ideas that you don't intend to be made into a final commercial product. So how do we set the sample rate? The sample rate of a project should be set before you start your first recording, obviously. All of the audio files used in the project should be recorded and played at the same sample rate. Otherwise, some are going to sound different to others. They'll play faster and whatnot. Okay, so playing an audio file at the wrong sample rate will result in the wrong pitch and tempo, much like playing an audio tape or a vinyl record at the wrong speed. It's going to sound weird. Like you all heard chipmunk versions of songs. That's what it could sound like if it's playing back at the wrong. If your sample rate is different to your project settings. So what we can do is we can go into our files, and you should find this in your CMS drive under Resources, Logic 9 Files, Logic Sessions, and then the session 02 New Day. Okay, so we need to open that and then file save as into your own discrete folders if you can. So I'm going to open it from my disk, so I'm going to go to File, Open. I'm going to close that particular file, save it, and I'm going to go to my Logic CD here and my lessons, and I'm going to go to 02 New Day. Okay, so I'm going to go straight to the toolbar and click the Settings button and choose Audio. Okay, so if we remember, that's up here. Okay, I'm going to choose Settings, Audio, and this brings up the Project Settings window. Okay, let's just bring that to the center of the screen. So on here you can see that we've got a sample rate set, and it's set to 44.1 kilohertz, which basically just means 44,100 hertz, or 44.1 kilohertz. That is our CD Redbook standard. Don't worry about what these other things mean for now, except for the fact that you can record at higher sample rates if you want to, for whatever reason. Okay, and there are reasons for recording at these different sample rates for different things. Okay, so for high quality professional audio, obviously we want to record at much higher sample rates, but that will create very big files, and you can't really do that on our computers. So I wouldn't recommend it unless you're actually using something for a commercial release, which you shouldn't be using the college's computers anyway. Okay, so don't worry about checking the surround sound format or anything like that. we've set the sample rate to 44.1. Okay, so data for an audio CD is encoded at a sample rate of 44.1 kilohertz, which is 44,100 samples per second, and audio data for a standard video DVD is encoded at 48 kilohertz. But we don't want to make music for a DVD or sound for a DVD. We want a CD, Redbook standard. Okay, because it's a music file and it doesn't need to be highly professional at the moment. Okay, so we can close that just by pressing Command W to close the window, or selecting the little red button up in the top left-hand corner. Okay, and what we're going to do now is we're going to set the bit depth. Okay, so in the toolbar, we're going to go to the Preferences button this time, which is next to the Settings button. You can probably see that. I'll just zoom in on it quickly. Okay, so if we go to Preferences and Audio, this brings up the Preferences section. Okay, so here from the Output and Input device menus, we can choose the desired interfaces. Now, I should have gone through this with most of you by now, but obviously, this tells us where we want to send our output to. At the moment, I've got this set to built-in output because that's all I've got. I don't have a sound card set up on this at the moment, but you will have your fast track set on there, so it will either say built-in output or it will say fast track. And if you're monitoring, if you're listening back with your headphones through the built-in output, i.e. from the back of the desktop, of the CPU, then just select built-in output. But if you're listening through the fast track device, through the headphones coming out of the headphone output on your audio device there, select fast track. Okay, and obviously for input at the moment, you can hear me because I'm using the built-in microphone to record. Okay, so you can have built-in microphone, and you will also have the fast track as an option. Okay, so you can select that. But down here, more interestingly, is a selection to select for 24-bit recording or not. And that basically just means if it's unticked, you're recording at 16-bit, and that's what I'd like you to do. Because if you don't want to record at 24-bit, it's too high for what you need to do. Okay, but again, professional recordings these days record at 24-bit for commercial releases, and also for future-proofing against any changes like developments in playback systems and whatnot. And actually, some of the developments in iTunes formats should be pushing us towards 24-bit downloads very soon. So, so that's the bit depth. Okay, and you don't have to choose 24-bit, but if you do, that creates a high-quality file, and a much higher file size. Just to give you an idea, what it means is that if you're recording at 16-bit, you can record up to around 65,000 heights in amplitude. Okay, so it can really finely describe at what point in the waveform you're at. Okay, but for 24-bit recording, it's something like around 17 million different levels of volume that you can levels of amplitude, in fact, is the proper terms that you can actually describe in that waveform. Okay, but for many of you, you're probably not interested in that. Okay, again, we can just apply changes or press Command W to close that, and that is your project settings and your and your audio settings and preferences set up. So when you come into record, you can use it. But also, you'll want to know that so that if you've done some recordings in another project, maybe on another, using some other software like Pro Tools, and you've recorded it at 24-bit, 96 kilohertz, or 16-bit, 44.1, and you want to bring that audio into Logic to edit it on a different platform, you can set your project settings that way beforehand, so that when you import your audio, it's already compatible. Okay, so that's the basics of it. There isn't much more to know, but so I'll leave it there. Any more questions, please do come and ask me in person. Okay, thank you.